Now this is a compound interest formula. That is, P is the principal invested, R is the interest rate as a proportion, M is the number of compoundings each year, and A is the final amount after T years. So for example, if the rate is 6%, R is going to be used as 0.06. Say the compounding is quarterly, then since there are 4 compoundings each year, M will be 4. So we will look at this example that say Jill has deposited $2,500 in a retirement account that will pay 4.8% interest compounded monthly. And it's a retirement account, and let's assume Jill is fairly young, say, maybe 19, 20 years old. So just deposit that there, and it's a good time to invest. And we want to know that how much money will she have in this account after T years, okay? So let's compare all the ingredients of our formula for this example. So here the principal is how much? $2,500. The interest rate is 4.8%, so as a proportion that changes to 0.048. The compounding is monthly. That means there are 12 compoundings each year, okay? Now that 5 was of course a mistake. So this is 10 years. So we have T equals 10 years in this case. That means that if we substitute all the values in here, the final amount after 10 years would be this entire quantity, okay? And in order to enter it in the calculator, it's a good idea. I mean, if we are not doing any calculations, just want to enter it straight as it is, we can write it like this. So say we have this computer, okay, sorry, this calculator, okay, and so you have 2,500 times 1 plus 0.048 over 12 to the power. You can write 12 times 10 or write 120 directly, and that's what you get, that the value is how much? $4,036.32 approximately. All right. Or if you want, you can see that 0.048 over 12 is 0.004. Just enter it directly and you get the same answer. Okay. So this was regarding one particular value. You can see a table of values in the following manner, that you know that the final amount in terms of T is related by this. So I can do this, that I can enter it like this in my calculator, right? See, just a second. So I have entered this quantity in this manner, and then I can go ahead and set my table, say is starting from 0. In the beginning there is $2,500, and we are going in increments of 1. Okay, you can go in the increments of half a year, or or lesser if you would like. Okay, and then we can ask for the table, right? So it shows us that how the amount is changing year after year, and we can see this table of values showing us the changing amount. All right, and you can keep scrolling down. It will give you the way the account grows. Now, of course, we can read it from the table that say we want to answer a reverse question. That is, how long will it take for this account to have, say, $25,000? I can go through table of values, see an approximate number, then go with a different delta t and get an approximation. But in this course, we have learned another technique, which is the inverse of this exponential function called logarithm. And what logarithm does is helps us solve these equations in which the variable that we are solving for is in the exponent. Okay, so we are solving this equation for t. So first thing we want to do is that we want to isolate t. So the first thing to remove here will be this 2500. So we will divide both the sides by 2500, and what that would do is these 2500s cancel, and my equation comes down to be just this 1.004 to the power 12t equals 10. Okay, so next we see that this 12t, I mean this is t is our unknown, so we would like to handle this, and what helps us do is this natural log, because one of its properties is that if I apply it on the exponent, it just brings the exponent down for us, right? So when we did that, then ln of 1.004 to the power 12t became 12t times this, and that equals ln of 10. Now I still have to do what? Just isolate this t. So I'm going to divide by these two coefficients. Okay, that is, this is multiplied with t, this is multiplied with t. I can do that like one step at a time, and or do that together just like this. So then t will be isolated because of these cancellations, and the answer will be the answer will come out to be this, right? And I can go ahead and then enter it on our calculator. Here is my ln key, and I get ln of 10, right, divided by, let's put parentheses just to be safer. Okay, then ln of how much? 1.004, and then what this tells me, that it will take approximately 48.07 years in order for this amount to grow 10 times of what it is right now. Okay, so let me know if this was not clear. Okay.